everyone. This is Morgan here from Positive Approach to Math. We are moving right along with lesson 2 in our equations topic. We are going to start solving multi-step equations, meaning there's going to be more than one step. Just a friendly reminder, if you look in the details below of this video, you will find a PDF that will lead you to a blank copy of this lesson and the U-tries, so you can either print them out for yourself or use a markup feature on a tablet. You will see an answer key to the U-tries, a link to the answer key, as well as a link to a video of the U-tries. So in case we get to those U-tries and you're a little bit stuck, or the answer key doesn't make 100% sense to you, and you just want to follow up to see where you went wrong, or you need a little bit of extra guidance or a little bit more examples, you can click on that video as well. As I said in our last video, this is one of my favorite topics. It's super important for any math class you're going to take beyond Algebra 1. So let's get started solving multi-step equations. So what it means to be a multi-step equation is obviously there's going to be more than one step to get the variable by itself. So that means we're going to have to apply more than one property of equality. So we're not just going to have to add on both sides and the variable will be by itself. We might have to add and then divide by something or something along those lines, okay? As we discovered in lesson 1, the awesome thing about solving equations is we can always check our work. So we can always substitute the value that we get as our answer in for the variable into the original equation to check our work, okay? A lot of this is, if you remember, PEMDAS, our order of operations, when we simplify expressions, instead of going parentheses, exponents, multiplication, division, addition, subtraction, in those order of operations, we always wiped out all of our multiplication and division first, and then all of our addition and subtraction. We're kind of going to work in this order for those two things 95% of the time. So you're going to use your addition or subtraction property of equality first, and then you're going to finish up with your multiplication and division property. So a lot of times people will say you're kind of working backwards from that order of operations. Okay, so let's just do a little bit of a recap here. Our opposite of addition, hopefully you can fill in that blank, is subtraction. Woo, a little bit big there. And the opposite of subtraction is addition. Right? So if I need to undo an operation, I do the opposite. And we use this term inverse, right? The opposite of multiplication is division. And the opposite of division is multiplication. Okay? So let's get right to it. So I'm going to slide this down, and I think one of the best ways to teach this is to kind of just dive right in, right? You're going to see this is the part where not every single problem is going to be exactly the same, but you're going to acquire the skills so you have the ability to solve them and recognize, okay, I need to do this or I need to do this. So let's just look right at our examples. So here's where we are building our foundation from lesson 1. So just like lesson 1, we put our line down the equal sign, same concept. If I add something on one side, I need to add it on the other to keep it balanced. And what I do to one side, I must do to the other to keep it balanced, right? So I put my line down to divvy up left-hand side versus right-hand side. And then I'm going to put my variable in the box. And in this case, I'm not just going to put the X in the box. I'm going to put the term with the variable. So in this case, it has the coefficient of 3. So we're going to include that 3X in the box. I like putting this box when I'm first learning how to solve equations, because once you see that box, it's really, really clear to see, okay, what is that opposite operation? So I see I need to get the box by itself. That's my goal. I only want the box on the left-hand side. So I see what's outside of the box, and hopefully you think, oh, -7 is on the outside of the box. So remember, we have to do the opposite of -7, which will be to add 7. That will get us our box by itself. And if I add 7 on the left, I need to add 7 on the right. And remember, when I move over my bridge, I do the opposite operation. So this is going to give us 3x. 5 plus 7 is 12. Okay, so that was step 1. We're not out of the woods yet. Our variable is not isolated yet. We're going to say, okay, we got that term by itself. Now I'm going to look again, and I'm going to say, okay, I really want to get x by itself. I want to get rid of that 3 as well. So now I'm going to say, how is that 3 connected to x? And because they're glued together, there's no operation in between. 3 is the coefficient. Remember, they're being multiplied together. So it's really saying 3 times x. Okay, so if that is 3 times x, I want to undo that multiplication. I want to do the opposite of the multiplication, which would be division. So I'm going to divide my left-hand side by 3, and if I divide my left-hand side by 3, I want to divide my right-hand side as well. That's going to get me x equals, and then 12 divided by 3 is 4. And my variable is by itself. Now remember I said about checking your work, so you can substitute 4 in for x. Remember that would become 3 times 4, not the value 34. Minus 7, and we want to see, does that equal 5? So now we're going to do our multiplication first because we're doing order of operations. So 3 times 4 is 12. Bring down the minus 7. Does it equal 5? 12 minus 7 is 5. And look at that. So remember, there's always a way, if you're like, that seems like a little funky of an answer, you can substitute it in. Okay. Next example, looking at our next example, we are tricking you here. We put our variable not on the left-hand side. That's okay, right? We can do that to you. And in real life, when we're dealing with word problems, that might be a thing. So some people, I'm going to show you without rewriting it, but some people like to always rewrite it and put their variable on the left. Go for it. I want to introduce to you and show you how to solve with the variable on the right because we're going to be getting more advanced and I want you to be able to just solve and save some time. So I draw my line down and I'm going to put my term with the variable in the box. So in this case, it's going to entail the negative 2y. Why I'm including that negative is because that's really going with the 2. It's not going with the 10, right? We read from left to right, okay? Now, if you look here, I want you to think, how is that 10 being connected to that y? And it's really positive 10 minus 2y. So that term is being added on the outside, right? So to move it over, because if you were to rewrite this, if you were to put the negative 2y first, you wouldn't just throw a 10 there. You would say, oh, it was a positive 10. So plus 10, right? And so if you put your variable first, it would have looked like that. Okay, so they're trying to trick you by putting the constant in the front, but you still need to subtract it. If it was a negative 10, we would need to add it on both sides. So I'm going to subtract 10 on the right-hand side, and if I subtract 10 on the right, you guessed it, I need to do it to the left. 20 minus 10 is 10. And I like to put my arrow here. I'm going to bring down my negative 2y. Now, this problem, I've been waiting to talk about something like this. Rookie mistake number 1 is the next step people go and do plus 2. And they think, oh, it was a minus 2, so I'm just going to add 2. But you have to look at how that negative 2 is connected to the y. So that's really saying negative 2 times y. Negative 2 is the coefficient. So negative 2 is being multiplied by the y, or y is being multiplied by negative 2. There is no plus or minus sign separating those two things. So they're glued together. And when things are glued together, remember, we're multiplying them. So to undo that multiplication of a negative 2, we're going to go ahead and divide by negative 2. Another rookie mistake is people say, well, no, you need to divide by positive 2. But no. The opposite of multiplication is division, right? Not division with the opposite sign, okay? So you keep the exact number that you see. You're going to divide by negative 2 because you want to get rid of negative 2 on the right-hand side. So 10 divided by negative 2 will give us negative 5. And negative 2 divided by negative 2 crosses out. They need to be identical, right, when dividing, and we're left with y. You could also go ahead and write it as y equals negative 5. Your teacher might require that you put the variable on the left. So if you have to rewrite it, you just switch places. Okay? So we wanted to show you something where the variable was on the right there. Okay. Next example, we're going to draw our line down that equal sign. W divided by 4, that is our term with our coefficient. So we're going to put that in the box. And you see that that plus 2 is hanging out on the outside. So I need to do the opposite of plus 2. The inverse operation is a minus 2. And remember, if I do the opposite on one side to move it over, I have to do the opposite on the other side. So if I need to move something over, we do opposite operation and we do it to both sides. I bring down W divided by 4. 8 minus 2 is 6. Okay? From here, I'm still going to put my W in the box. And you'll see after that first step, it boils down to what we were doing in lesson 1. It's now a one-step equation. So we're just kind of going backwards. We did one step, now we're climbing up, or do two step, and hopefully you're going to see how we're going to progress. So now the W we need to get by itself. What's happening on the outside is it's currently being divided by 4. So we want to do the opposite of division, which is multiplication. So we're going to multiply by 4. What we do on one side, we must do on the other to keep it balanced. That's going to leave us with W, and 6 times 4 will leave us with 24. Remember, you can always substitute that back in. You can do 24 divided by 4, which will leave you with 6, and 6 plus 2, which will leave you with 8. So it does match. Okay, and now last but not least, this is the one scenario that we're going to see where we didn't work, or we're not going to work in the backwards or the opposite order of PEMDAS, okay? So look at this fraction in this example and compare it to the fraction that we just dealt with. We dealt with a really skinny fraction, and now we're dealing with a beefier, chunkier fraction, right? I want you to recognize that the plus 4 that's attached to the z is also being divided by 3. Whereas in the example we just did, the plus 2 was not being divided by 4. Okay? So when you have your plus or minus with your variable, it's really chunky, and then both things are being divided by one number, right? What we're really going to be putting in our box is that z plus 4. We can't go and subtract 4 first like we did in the previous example because it's also being divided by 3. So we need to kind of set that division of 3 and get rid of it. So then that plus 4 has the freedom to move, right? So I call these my beefier fractions. They're not the super skinny ones. And when we see those beefier fractions, we need to get rid of this first. I can't do anything with z or plus 4. They're kind of like glued together with addition, and they're locked in the house because of that division of 3. So we can't set them free until we undo that division of 3. So hopefully you recognize the difference between the example we just did, what that fraction looks like. It's a fraction plus a number versus a variable plus a number, all divided by that fraction. So I need to get rid of that division of 3. So I'm going to do that by multiplying by 3. Okay? When I do that here, I am not distributing that 3 to the things in the box. What's happening, they're in the box, so we cannot touch them, right? We haven't touched that 3x. We didn't touch when we did something. We just brought it down. Negative 2y, we just brought it down. It did not alter when we went to subtract the 10, right? So when I go to multiply by 3, that's not going to alter what's in the box. That's important to note. So that's just going to give us z plus 4. And then 5 times 3 will give us 15. Okay? Now here we have our one-step equation. We want to get z by itself. So we see, okay, I put it in the box. How am I going to get z by itself? What's the opposite of plus 4? Hopefully you're answering that on your own. Draw my arrow down. It was a little hard to draw an arrow there, right? So we have z. I'll put my line through my z's so they don't start to look like 2's. And 15 minus 4 is 11. Awesome. So hopefully that helps with some two-step equations. We really want to drill this because if you get this down, it's going to make all of the lessons that follow go smoothly. So a little helpful hints, a summary to wrap up everything we just talked about is we're going to think of working backwards in our order of operations. So in order of operations, we typically do the multiplication and division first, and then addition or subtraction. Here we're kind of undoing the addition and subtraction first, and then we're going to do our multiplication and division. However, the only time we won't do that is if we see that beefy fraction where it's a variable plus something all divided by a number. When in doubt, you can always check your work. You're going to see me say that in every single lesson in this topic because you can always substitute your value in to your equation and make sure your left-hand side and right-hand side are balanced. And then our goal here is to always, always, always isolate our variable completely. That is algebra. Get that variable by itself, right? So I left you, I'm taking a peek at these 6 problems I left you with to try on your own. They look really good. I did not give you any tricky ones with the variable on the right, so you're welcome. So remember, you can try them on your own. I think you can do it. And then if you want to check your work, there is the key in the details below, a link that will take you right to a PDF of my worked out solutions, or a video that will break down those 6 problems for you. So we're going to keep moving along. What's coming next is our multi-step equations part 2. So keep up the great work, and I'm super proud of you.